Welcome to my channel. I am Komal Sharma and together we make maths easy. And what are we about to talk today? We will be talking about problems on upstream and downstream. I do not know why, but children find it very difficult, the upstream and downstream problems. But I'm sure by the end of this video, you will start liking these problems as I will clear up your concepts regarding the upstream and the downstream problems. So there are certain things we will talk about before jumping into the problem. The first thing you have to understand is that supposing this is a river and water is flowing in this river. Okay. So this is the river and this is the direction of flow of the river. The river is flowing from my left towards my right. This is the direction of flow. So if there is a man who is rowing a boat or swimming, let us say this is a boat and this becomes the direction of rowing. So if the direction of flow is along the direction of rowing or both are along the same direction, then this is known as downstream. Along the river, if it is flowing, the river is flowing in this direction, the boat is also going in this direction. So we say it is going downstream. So you can understand that if the person is going in this direction and the flow is also in this direction, like my friend is going in this direction cycling, and if I push the cycle, then what is going to happen to the speed? The speed will increase. So in this case, the total speed will be equal to the speed of rowing plus speed of the river flowing. So downstream means along the direction of flow and both the velocities will add up. Now what about upstream? This is the direction of flow. Now supposing the boat person decides to go in this direction. This is the direction of flow and this becomes the direction of rowing, opposite to the direction of flow. So this is known as upstream. So now what is going to happen? One speed in this direction and the other speed in this direction. So what will be the total speed? It will be the difference of both. Okay, like my friend is cycling in this direction, I am pulling him back in the other direction. So what will be the speed with which he will cycle? It will be his speed minus my speed. Agreed? So we have to take care that in downstream the speeds add up and in upstream the speeds subtract. And always it will be boat plus stream in the case of downstream and boat minus stream in the case of upstream. Sometimes the students tend to write down stream first and then they commit mistake. So let us say it is alphabetical. B comes first and S comes after that. So boat will be always first and stream will be after that. So what have we understood if we are concluding? Downstream means both the speeds will add up, boat plus stream, and upstream means both the speeds will subtract, that means boat minus stream. So the question says, a person rowing at the rate of 5 km per hour in still water and takes thrice as much time in going 40 km upstream. Upstream means opposite to the direction of flow. When you move opposite to the direction of flow, naturally you will take more time. As in going 40 km downstream, find the speed of the stream. So two unknowns, speed of the boat and speed of the stream. One is already given, you have to find out the second one. So write down, let the speed of the stream be x kilometer per hour. So downstream speed. Downstream means along the river. Along the river it will be boat plus stream, and upstream speed means opposite to the direction. So we have already discussed, it will be 5 minus x. Now you have to relate between speed, distance and time, thrice as much time. So what is the relation? Speed is equal to distance upon time. Now in the first case, when he is moving upstream, so time will be equal to, let me say this is the first time, it will be equal to distance upon speed. What is the distance? 40. What is the speed? 5 minus x. Agreed? Now second case, downstream. Let us find out the time again. It will be equal to distance upon speed. Okay? But you are given a condition according to the question. He takes thrice as much time in going upstream. That means time upstream is equal to thrice time downstream. Agreed? Now just substitute the values. What is the time upstream? 40 upon 5 minus x is equal to 3 into 40. And what is the time downstream? 5 plus x. Agreed? Form a word equation, substitute the values. Cancel this, you're left with 1 and this cancels out. Because it is multiplication, you can easily cancel. Now cross multiply. So 5 plus x is equal to 3 into 5 minus x. Open the bracket. 5 plus x is equal to 15 minus 3x. This comes to this side. So you get 3x plus x, 4x. This comes to the other side. You get 15 minus 5, which is equal to 10. So x is equal to 10 upon 4. So x is 2.5 kilometer per hour. So this is the speed of the stream. So let us look into another very important and very interesting and also a real life problem, because sometimes children ask, where do we use this? We study this, but where do we use this? So let us apply this to a real life problem. The problem says a motorboat can travel 30 km upstream and 20 km downstream in 7 hours. It can travel 21 km upstream and return means again 21 km downstream in 5 hours. Find the speed of the boat in still water and the speed of the stream. Two unknowns, let the speed of still water be x and let the speed of the stream be equal to y km per hour. So speed downstream. Downstream means you are going with the flow of the river. So it will be boat plus stream, and upstream will be opposite, means x minus y. And always it will be boat minus stream. Boat plus stream and boat minus stream. Now the first case. Boat can travel 30 km upstream. 30 km upstream means the time required is what? We know that speed is equal to distance upon time, or from here we can say time is equal to distance upon speed. So what is the distance? 30 km per hour. What is the distance? 30 km. And what is the speed? we are talking about upstream. What is the speed? X minus y plus. What about downstream? What is the distance? 20 kilometer. And what is the speed? X plus y. And what is the total time taken? 7 hours. So we have got our first equation. Now in the second case, what is the distance? 21 kilometer. Upstream divided by upstream speed plus 21 kilometer again divided by downstream speed is equal to 5 hours. Now we have got these two equations. The first is this and the second is this. Now how to solve these equations? These are again special equations. You can also get them as questions to solve and find out the values of x and y. So let us see how to solve these equations. So these were the two equations we got. 30 upon x minus y plus 20 upon x plus y is equal to 7 and 21 upon x minus y plus 21 upon x plus y is equal to 5. Now these are equations, if you take LCM and try to solve them, you will not be able to solve them. So these are special cases which need a particular way only to solve them. So let us learn this method also. So in this case, we will put 1 upon x plus y is equal to u and 1 upon x minus y is equal to v. So over here, if I put x plus y is equal to u and 1 upon x minus y is equal to v, so this part becomes what? U, and this part becomes what? V. So the equation changes to 30v plus 20u is equal to 7. And in this 21 and 1 upon x minus y, I'll put v plus 21u is equal to 5. This becomes the next equation. Agreed? This is 28 here. Let us make it 28. Agreed? Now how to solve these? If you multiply these, they become a bit longer in calculation. So let us divide equation 4 by 21. So this becomes v plus u is equal to 5 upon 21. Now multiply by 28. Why are we doing this? So that we can make this coefficient equal to 28. So I will write these equations. 30v plus 28u is equal to 7 and multiply this. So this will be 28v plus 28u is equal to 5 upon 21 into 28. Now when you solve and subtract, this gets cancelled. So over here you are left with 2v, and when you subtract, you will get 1 upon 3. This will get cancelled. This will be 4. So this will become 20 upon 7. So 7 minus 20 upon 7, it will give you 1 upon 3. Agreed? So v becomes what? 2v is equal to 1 upon 3. So v becomes 1 upon 6. This is the first value we have got. Okay. Now find out the value of u. So u is what? But v plus u is equal to 5 upon 21. So u is equal to 5 upon 21 minus 1 upon 6. When you calculate this, it becomes 1 upon 14. So you get the values of u and v. But are we required to find out the values of u and v? No. We have to find out the values of x and y. So 1 upon v means 1 upon x minus y is equal to 1 upon 6. From here you get x minus y is equal to 6. Okay? And from here x plus y is equal to 14. Now you have these two equations and you have to solve them for x and y. So x minus y is equal to 6 and x plus y is equal to 14. You add both these equations, this cancels out, you get 2x is equal to 20 or x is equal to 10. Substitute, you will get 10 plus y is equal to 14. So y you will get as 4. So you can say that the speed of the boat is 10 km per hour and the speed of the stream is 4 km per hour. In case you have any other doubt regarding the upstream downstream problems, you can give it to me in the comment section. Until we meet next, keep learning, keep solving and keep shining. Thank you.